Okay, statistics 5.2 is the addition rule, which means or, and it has everything to do with Venn diagrams. It's the probability of an event E or event F occurring is probability E plus probability of F minus the probability of E and F. This has basically everything to do with a Venn diagram. If I'm looking for the probability of E and the probability of F, I count everything in E and I count everything in F. The middle gets counted twice because it's in both E and F. So it has to be subtracted off so that it can only count once. If you were looking for all the people who were male and college students, a male college student would not count twice, but if you counted all the males and you counted all the college students, you would have counted them twice, so you need to subtract them off once. So let's think of a spinner. Looking at the picture, what's the probability of spinning an even number or a number greater than 5? Well, we can see the even numbers are 2, 4, 6, 8. The numbers greater than 5 also includes 7, so it would be 5 over 8, because 2, 4, 6, 7, and 8 are either even or greater than 5. Now let's do it using the formula. What are the chances that it's even? 4 out of 8. What are the chances that it's greater than 5? 3 out of 8. Now which numbers are even and bigger than 5? 6 and 8. So that would be 2 out of 8. 4 plus 3 minus 2 is 5 out of 8. Is that probability an even number or a 3? Okay, so even numbers are 4 out of 8. 3s are just 1 out of 8. Are there any even numbers that are even and a 3? No. So we aren't subtracting anything off, so it's 5 out of 8. So one thing to note, when events can't occur at the same time, they're called mutually exclusive. That's when there's no overlap, so there's nothing to subtract off. The addition rule for disjoint events can be extended to more than 2 events. Basically, if they have no overlapping area, you can do it for as many events as you want. It becomes harder when they overlap because there's a bunch of middle overlapping. Like if 3 events overlap, then the stuff in the middle is counted 3 times. It's all sorts of complicated. But if there is no overlapping, you can just add the probabilities together. So the probability model to the right shows the distribution of the number of rooms and housing units in the United States, and it's 1 through 9 or more. What is the probability a randomly selected housing unit has 2 or 3 rooms? You would just add the numbers for 2 and 3 together. Why? Do we not have to subtract anything off here? Well, can a house have only 2 rooms and have 3 rooms? Like the total number of rooms, can it be 2 and 3? No. So these are all mutually exclusive. What is the probability a randomly selected housing unit has 1, 2, or 3 rooms? Same thing, we just have 1 thrown in there as well. It's 0.135. If one card is randomly selected from a standard deck of cards, find the probability king or queen. So 4 out of 52 are kings, 4 out of 52 are queens. No card is a king and queen, so there's nothing to subtract, so it's 8 out of 52. We can reduce that to a decimal if we would like. Let's go ahead and do that. Its reduced fraction form is 2 out of 13. This should be about 0.154. Yeah, 0.154. Now a diamond or a 5. There are 13 diamonds out of 52 and 4 5s out of 52. However, you have to ask yourself, is there anything that is both a 5 and a diamond? Yes, the 5 of diamonds. There's exactly one of those. So if it gets counted twice for both of them, we have to subtract it off. This becomes 16 out of 52, which is approximately 4 out of 13 reduced, but that's 0.308. So twice as big as that. a red card or a 7. 26 out of 52 cards are red. 4 out of 52 cards are 7. Are there any red cards that are a 7? Yes. The 7 of hearts and the 7 of diamonds. So we need to subtract 2. This whole thing is 28 out of 52, which can be reduced. It's 7 out of 13, which is a decimal 0.538. Okay, if we can do cards, we can do dice. These are, again, all the possible rolls when you roll 2 dice. Suppose a pair of fair dice are thrown. Let E, the first event, be the first dice is a 2, and F be the sum of the dice is less than or equal to 5. So how many dice have the first one as a 2? Looks like this whole row of 6, so that's 6 out of 36. How many of a sum less than or equal to 5? It's all of these. So it looks like 10 out of the 36. Now, are there any overlapping? So are there any in this area that I circled that also start with a 2? Yes, there are 3 of them that got counted twice. This ends up being 6 plus 10 minus 3 is 13 out of 36, which is approximately 0.361. Now some general problems. The probability of E equals 0.25 and the probability of F equals 0.45. Find the probability of E or F if P, E, and F is 0.15. So this is just completely theoretical. Remember, to find the probability of E or F, it's the probability of E plus the probability of F minus the probability of E and F. So that would be 0.25 plus 0.45 according to the problem, minus this 0.15, which is 0.55. If they're mutually exclusive, that means the probability of E and F is 0, so we just add the 2 together. Probability of E complement. When it says complement, it's 1 minus the probability of E. So 1 minus 0.25 is 0.75. This is the probability of E is 0.6, the probability of E or F is 0.85, and the probability of E and F is 0.05. Find probability of F. So this is about the equation. The probability of E or F equals the probability of E plus the probability of F minus the probability of E and F. So generally speaking, E or F, 0.85, equals 0.6 plus the probability of F minus 0.05. All we have to do is solve the equation for the remaining variable, which is the probability of F. So let's subtract 0.6. This means 0.25 equals the probability of F minus 0.05. Add the 0.05. You get the probability of F equals 0.3. And we will continue in the next video.